Now for our next set of examples wherein the given function is y equal to ln of x plus 2 over x minus 2. So as you can see here, our given u here is a fraction or a quotient. Then finding the derivative of this function, again, it is better to find the derivative of this u first. Then using the quotient derivative, so we can find the derivative of x plus 2 over x minus 2, wherein x minus 2 is our v or denominator and x plus 2 is our numerator or u. So by using the quotient derivative rule, we have to get the derivative of this u by squaring the denominator. Then for the numerator part, it should be denominator first times the derivative of numerator, which is 1, minus the numerator times the derivative of denominator, which is also 1. And then we can simplify this by just simply multiply the 1. So this is also x minus 2. And then remove the parentheses. So we have to change the signs of all these subrahend. So this is now x minus x, and that will be 0. And then minus 2, and that will be negative 4. Then divided by the denominator of x minus 2 raised to square. Then for the given function, we can say that this is now the derivative of y with respect to x, or if you want to use the y prime, so this is also equal to y prime. And then for the derivative of logarithmic function, as natural logarithmic function, this is just simply 1 over u, and then to be multiplied by the derivative of the u. Then simplifying for our final answer, so for this 1 over u, we can express as numerator to be multiplied by the reciprocal of denominator. So it can be expressed as x minus 2 over x plus 2. And then to be multiplied by the derivative of u, then we can reduce the x minus 2 here and the denominator as x minus 2 raised to square. Then we can have as x plus 2 times x minus 2 for the denominator, or we can also multiply the denominators as spatial product. So this is also the square of the first minus the square of the second, or just simply this is equal to negative 4 over x squared minus 4. So this is our derivative of that given function. For number 6 example, we have this time that the function is y equal to log of x squared to the base 3 plus log of 3 to the base 3. Now, if we're going to review or recall the logarithmic property that if they have the same base, you can express the sum into product. So this is log of m to the base a plus log of n to the base a can also be expressed as log of m times n to the base a. So then, instead, our function is now expressed or simplified as y equal to the log of 3 x squared to the base 3. So then, instead, we have now that the value of our u is 3x squared. Then, finding the derivative of this u with respect to x is now equal to 6x. This is by means of power derivative. Bring down 2 times 3. And then less 1 from the 2. So this is now 6x. And for the given function, this is now derivative of y with respect to x as equal to 1 over u. And our u is 3x squared, to be multiplied by a constant of log of e to the base 3, and then to be multiplied by the derivative of u, which is 6x. And then simplifying, we can reduce the 6 and 3 as 2. And then x over x squared is now 1 over x, or our final answer is that derivative of the function y with respect to x is now 2 over x, and then log of e to the base 3. And for our last example, which is y equal to log of x squared to the base 3 plus log of 3x to the base 2. So this time, they don't have the same base, so we cannot express into product. So what do you mean by this is we have to differentiate each term with respect to x. So this is now that our derivative of the function with respect to x is also expressed as y prime. So for this first term, this is our u, then the derivative of this log of x squared to the base 3 is now 1 over x squared to be multiplied by the derivative of x squared, which is 2x, and then multiplied by a constant value of log of e to the base 3. Now for the second term, this is also 1 over u, which is, our u here is the 3x, so this is 1 over 3x, to be multiplied by the derivative of 3x, which is 3, and also to be multiplied by a constant of log of e to the base 2. Then we can also express as, for the first term, because we can reduce this by x, so this is also as 2 over x log of e to the base 3 plus, this is log of e to the base 2 divided by x, or we can express into one fraction because they have the same denominator. So we can express that our denominator here is x. Then for the numerator part, this is just simply the sum of 2 log of e to the base 3 and log of e to the base 2. So our final answer as for first derivative of y is 2 log of e to the base 3 plus log of e to the base 2 all over x.